Welcome to Lesson 6. In this lesson, we'll provide you with an introduction to object-oriented programming. Now, as you can see from the topics, there's a lot of information that we're going to cover in this particular lesson. Hang in there with me, and we'll go ahead and cover all of these hopefully in a way that you can understand it quite easily. Toward the end of this lesson, you're also going to see a video demonstration, a desktop video demonstration of how to set all of this stuff up and work with it inside visualstudio.net. You may be asking yourself, why should an object-oriented version of COBOL be necessary, and why should it be of any interest to you? Well, the answer is that in order for COBOL applications to evolve, the COBOL language needed to evolve. COBOL is a living language. Over the years, the COBOL language and the standard for COBOL language has evolved to allow COBOL to keep up with the latest approach to application development, hence object-oriented COBOL. Object-oriented design and programming is a widely accepted development technique, and it makes sense that COBOL should facilitate the implementation of object-oriented designs. As we all know, COBOL has long been recognized as one of the best languages for business applications. The .NET framework provides access to the latest .NET technologies, and it is an object-oriented implementation. So, in order for COBOL to leverage the .NET framework, it's necessary for COBOL to be an object-oriented language. It's also essential for you as developers who wish to leverage the .NET framework to be able to understand object-oriented programming concepts. One of the major attractions for object-oriented design and development is that it seeks to create a design model that matches real-world objects. For example, a bank has customers and accounts. Conceptually, that's a very concrete and very tangible thing for everybody to understand. From a systems perspective, an object-oriented banking system has customer objects and account objects. In this example, there is a direct one-to-one correlation between a real-world object and an object-oriented design implementation. Both the customer and account objects contain or encapsulate data and model or manifest the relevant behaviors of customers and accounts. One of the other tangible benefits to object-oriented design is the ability to reduce the impact of data changes through the encapsulation of data. Now, unless you've been writing or maintaining state-of-the-art 1960s and 1970s COBOL code, you should have a reasonable understanding of modular programming technique. Most COBOL programmers have been coding in this way for a couple of decades, in standard procedural COBOL through the use of perform or call statements. In object-oriented COBOL, there is a very high degree of modularity, as we'll see later on when we talk about objects and methods. Another key capability of object-oriented programming is the ability to reuse code or modules by identifying related objects and allowing them to share properties and behaviors through inheritance. Much has been made of the reuse features of object-oriented design and development. In the COBOL world, we would use procedure division copybooks to do much the same thing, with the objective of gaining greater coding productivity through the reuse of common code. The same is true in the object-oriented world. As you can see, there is much that is different, and much that is the same. From a conceptual perspective, you may not be as far away from an understanding of object-oriented technologies, design, and programming as you may think you are.